Okay, so in the last video, I showed you how to simplify variable expressions. And in this video, we're going to take that one step farther, and I'm going to show you how to simplify variable expressions when they need you to use the distributive property. You may remember the distributive property from a while ago when we were talking about properties of numbers. And it's something that I told you guys right now might not make a lot of sense, but when we get to algebra, it will. Well, here we are in algebra, and we're going to look at why using the distributive property can be so helpful in simplifying an expression. So on the next page in your notebook, our objective for the day is I can simplify variable expressions that require an understanding of the distributive property. The heading is Simplifying Expressions with the Distributive Property. Make sure you put the date and the page number and all that good stuff so that your notebook is nice and organized. So let's go ahead and review what the distributive property looks like. And please write all of this down in your notebook as always. If we have something like this, 3 parentheses 6 plus 2, first thing we have to remember is what this 3 is doing to the parentheses. And I think I've talked about lazy mathematicians before in this class, and you'll hear me say it again and again. Mathematicians are kind of lazy. If they don't have to write something, they're not going to. So what they're not writing here is that 3 is actually multiplying by whatever's in the parentheses, okay? And they just didn't feel like putting a multiplication symbol. And it's not really that they're lazy, it's that because a multiplication symbol looks like an X, and so when you get into variables in algebra, it can get kind of confusing. So they just kind of left that multiplication symbol out. We can use a little dot to keep it less confusing as well. So when we were learning about the distributive property, we said, okay, this 3 is going to get distributed to the 6 and also the 2. So in reality, this expression can be written as 3 times 6 plus 3 times 2. Notice the 3 goes to both numbers in the parentheses. This would then simplify to 18 plus 6, which would take us farther to 24. Okay? So that's how we did the distributive property. And we also talked about the fact that if you did what's in parentheses first, like order of operation tells us to, inside the parentheses, 6 plus 2, that's going to equal 8. And if we then multiply it to this 3 on the outside, that is also going to get us 24. So we kind of proved that distributive property is still going to get you the same answer as order of operations, right? Remember that? Okay, so now let's actually apply our understanding of the distributive property to variable expressions that have variables. So we have 3 times x plus 2. Remember that the hidden operation between the 3 and the parentheses is multiplication. So we are going to use the same process for distributive property here. We are going to take the 3, distribute it to the x, and distribute it to the 2. So when I rewrite this, it's going to be 3 times x plus 3 times 2. And when I go to simplify it, there's not much I can do right here besides be a lazy mathematician. So I'm going to, and so are you. You're going to turn this 3 times x into a simple 3x because there is a hidden multiplication symbol between the 3 and the x, and we're going to be lazy mathematicians. And then we're going to add to that 3 times 2. We can actually do this multiplication. That is going to be 6. So our expression 3 parentheses x plus 2 can be simplified to 3x plus 6. All right, are you with me so far? Because now is where it gets a little interesting. Actually not yet. This one's pretty simple too. But let's work through this just for fun. And then it'll get interesting, I promise. Write this one down and see if you can try and use distributive property to simplify this on your own. I'm going to count down to 10, from 10, sorry, and make sure you pause the video within that 10 seconds and actually try and solve this one on your own. Don't just pretend and say you did. Actually try it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oopsie, I didn't hit pause. The answer you should have gotten is 6y plus 12 because I took my 2, multiplied it by 3y, got this right here, and then I did 2 times 6. 2 times 3y, I can just multiply the 2 and the 3, which gives me 6, and then I have y also. And then 2 times 6 is 12. So you should have gotten 6y plus 12. I have a lot of people who try to then combine these two numbers and end up with 18y. That is completely wrong. Ooh, not sure why I just did that. You might remember from our video yesterday that you can only combine like terms if they have the exact same variable part. 6y has a variable of y, but 12 has no variable, so you can't combine these two. 6y plus 12 is your final answer. Okay, let's go ahead and talk about this one because I think this is lots of fun. Very complicated because it starts throwing in negative numbers and two sets of distributive property. So I'm going to work through this one. Make sure you write down everything I write down, and then you're going to have a chance to do it on your own. So anytime we have subtraction, what are you supposed to do? I really hope at this point that you can answer, rewrite it as adding the opposite. So I'm going to rewrite this whole expression. 2 times 8m, subtraction is going to turn into adding negative 4. This subtraction is going to do the same thing, adding negative 5, parentheses, 6m plus 3. Okay? Now we can actually go through and use the distributive property. 2 times 8m plus, we have to do 2 times negative 4 as well. 2 times negative 4 plus negative 5 times 6m. Negative 5 times 6m plus negative 5 times 3. I'm just doing things you already know how to do. Use the distributive property. It just so happens to be that it is a longer problem, and that's completely okay. So now I'm going to have to actually start doing some multiplication and simplifying this. 2 times 8m. I'm going to multiply the numbers to give me 16, and then it's going to have the m right there. Plus 2 times negative 4. Don't forget your rules of integers. A positive times a negative is a negative. So that's going to give me negative 8 plus negative 5 times 6m. Negative 5 times 6, that's a negative times a positive, so I'm going to have a negative. 5 times 6 is 30, and then I have my m. Plus, last little bit, negative 5 times 5 is going to give me negative 15. Now, I'm not done yet because I can combine like terms. I have a term here that has a variable of m. A like term is going to be this one over here, negative 30m. So I need to do 16m plus negative 30m. Don't forget your rules of integers and your rules of simplifying. If they have the exact same variable part, I'm going to add my coefficients. These have different signs, so I am going to find the difference between 16 and 30. Do some scratch work over here on the side. Extend my page because I'm running out of room. 30 minus 16 is 14, but this has more evil soldiers than good, so it's going to be negative. And then I'm going to keep my variable part. So 16m plus negative 30m is going to be negative 14m. I'll use a different color now. And I have negative 8 is one of my constant terms, and negative 15 is my other. So I'm going to add those together, negative 8 plus negative 15. These have the same sign, so I'm going to find the sum. 8 plus 15 is 23. They are both evil soldiers, so I'm going to end up with evil 23 or negative 23. Add those two terms together, and I have my final answer of 14m plus negative 23. Oh, negative 14m, sorry. Almost left that out. And see how much more simple this is than our original expression right here? This is going to be much easier to evaluate for a given value of m, or much easier if this was set equal to something else to solve for what m would be. We're going to get into solving equations next week. So we combine our like terms, we use distributive property, follow all our rules of integers, and end up with something that's nice and simple. You have to be careful though. There are so many places here that you can make a little mistake. All right, so this is your reflection question. I want you to try and do this question. Give me the answer in Edmodo when you turn in your assignment, and really be careful with those positives and negatives, okay? Have a good day.